Hi, I'm Guohan. I'm from Microsoft. So today I think with Brian we're going to introduce our first SONiC community hardware testing lab, which is going to be used by the community and help to improve the qualification and validation of the hardware and software on SONiC. Yeah, so in this talk we'll go over the purpose of this lab and the infrastructure, physical infrastructure for this lab, and then what kind of topologies we're supporting in this lab, and go over briefly the test plan and how do we get access to the lab. And last one is call for participation. So we need all you guys to help together to build a lab so you can build it better and then testing more hardware and make SONiC quality better. So this lab we call the SONiC Community Hardware Testing Lab, and this is hosted and maintained by University of New Hampshire Interoperability Lab, and this is on behalf of SONiC project. So the purpose of that, SONiC is an open source project. We run the software on a lot of different hardwares. Right, so therefore, when people come, especially the new one coming with to the SONiC community, they want to know, hey, how does the image quality running on different types of hardware? Does this image support this feature, or is this feature supported on other hardware platforms? Right. So currently, I think we do not have that kind of visibility on a per hardware platform, per image, per feature-wise, what is the quality, whether these features are supported on a certain image or hardware. So the purpose of this lab is, one of the purposes to providing such visibilities, because in the SONiC, we not only open source the image, but we also open source a set of integration tests where you can run with on a real hardware and validate the feature. For example, we have a lab that have a hardware that can set up the BGP and then can run some tests like a BFD, VXLAN. So we have all those tests that are being automated and also open sourced so that people can run it. But somehow, those type of tests is running by each individual team, and we do not have a community testbed to run those tests to provide those results and visibility to the community. So one of these labs, the purpose is to be able to get hardware from the community and then be able to run those tests on those test beds, and then eventually we can publish those results to a dashboard where people can go and see whether those tests are passing or not, to see whether those features are working on a particular platform or not. And also another purpose is that because all these tests has been automated, meaning that we can run them in a nightly manner. So basically, whenever we check in the development process, whenever we check in an image feature, we can also run those tests in this community lab, and then people can see whether those image check-ins could have regressions, and if we have regressions, we can immediately either do something to fix those issues. So this both helps the community to understand the feature for different images, and also help on development to know whether the regression happens in the development process. So currently, we started the lab with 2 racks, and in the racks, I think it's each rack have 8 kilowatts available, and we are targeting to host 10 different test bed. So the lab infrastructure is, we have the management network to provide the accessibility to those switches, and then we also have the servers to generate the traffic, to send the packet to verify whether the data plan is working or not. And then we'll have this VPN for people to get remote access, and also remote PDOs for people to, power cycle the device in case the device is dead or something happened to the lab. And also, we have the lab hosting sites will also provide some hardware debug. For example, if a cables is wiring wrong or link is not, you can do some troubleshootings on that front. Okay, so this is the basic, the physical testbed setup. And I think we'll go over the physical, and then Brian will go over the logical and what is actually hosting it. So think about when we're testing the switches, what we really need to do in this lab currently is testing those switch forwarding functionalities. So basically, we're testing those layer 2 and above functionalities. So what we need to do really testing is that we'll be able to talk to a switch and send the commands to switch certain configurations, and at the same time we can send the packets to the switch and make sure the packet's being forwarded correctly by the switch. So because of this is our target, so what we did is that we connect two physical switches back to back. So you can see every port, on the top side is the device under test, which is a target device. We're trying to test all the features on that upper switch. And on the lower side, we call this is a leaf fan out switch, or sometimes we use it as a control switch. So this switch is basically used as a fan out, where we have this switch could also connect to a server, where the server have a NIC connect to one of the ports on this switch, so that the server can send a packet to this fan out, and the packet will go to the corresponding port of the DOT, and then that packet, if the switch being programmed correctly, the packet will forward to the right port or being transformed correctly. So we use that as a basic setup of our physical infrastructure, and then on top of it, we can derive a different logical topologies where you can test, a few ports of the switch or all the ports of the switch, and you can validate various different forwarding features. Oh, this is okay. Yeah. So, and this is more detailed this diagram of this switch. As you can see, on the last one, there is the additional server where we have the VM and the containers running on that server. That VM and container is served as a control machine and is running the test cases on that server. But the server also be able to send the traffic, generate the traffic, and that's from the server's NIC and to the service port of that control switch, and then it will be able to fan out to one of the leaf fan out ports and then go to the the DOT correspondingly. And then we also have, as you can see, we also have hook up the management port of the switch and also the console port of the switch. So, and the PDO I think is not shown here is also hooked up, so I have a completely remote control of the switch. We can power cycle the switch, and we can go to the console in case the switch is not accessible through the management network. We can also, be able to access the switch.
Thanks, Guohan. So on top of this basic back-to-back topology, we're able to realize a number of different test scenarios. But before we get to the test scenarios, it's important to consider why we built the topology this way, and a lot of that has to do with isolation. So from a lab perspective, the physical access is limited to the UNH IOL staff. And that's why we wanted to have a lot of the remote management and management capabilities in place, so that members of the community can do the power cycling if there's a device problem. If a device is irrecoverable and can't be re-imaged using SONiC upgrade, the ability to do so via the console ports. and then also an ability to run those tests from a remote perspective. The other thing, one of the reasons why we didn't pursue the standard root leaf fan-out topology that's used in other SONiC testbeds is because we wanted to provide each company that provides equipment their own physical and logical space. So from a physical perspective, vendor's device is only connected to another vendor's device, and we may add one additional test server in place there. From a logical perspective, we've segmented each testbed into a separate VLAN, which provides an ability to do user-based access control to the testbeds. So specifically in the environment, we have routing restrictions. We don't allow for routing between testbeds, and we enforce that users that are coming in are assigned only routes that are applicable for the testbeds they should have access to. So from a logical testbed topology perspective, the good news is this topology allows us to support different types of topologies and testing frameworks. On the SONiC management front, we support T0, T1, PTF in the same way. These topologies do require that optional test server to generate and receive packets through the leaf fan-out switch, and then ultimately to the DUT and back. There are other types of topologies. There's another type of virtual topology that we wanted to introduce, which is what we call the mirror topology at Google. And we also want to run some tests that are from Google but have been contributed to the open source. Specifically, OpenConfig Andatra tests for testing configuration and telemetry, and PIN's ThinKit tests, which test the P4 programmability of the data plane. So in this case, we actually don't need a test server, although the test server could be helpful. But we are able to drive these tests remotely, and we use P4 runtime, GNMI, and GNOI interfaces over the management network to drive packets into the control switch, and then we're able to monitor them as they either are punted from the DUT or routed to another port back on the control switch and then punted back to the test framework. So from a testing plan perspective, we currently have plans to hook up 2 automated test frameworks. The first is connecting Microsoft Azure pipelines and the SONiC management runners that run in those pipelines to the physical hardware lab over an IPsec tunnel. And then we also are establishing connectivity from GCP down to the test lab as well, where we're able to run the Andatra and ThinKit-based tests. For now, we're manually mapping testbeds to test frameworks, but we're hoping that in the future we may be able to have a scheduler that would enable us to dynamically adapt different test frameworks to different testbeds. We're also open to adding other test frameworks in the future. If you're interested in providing a different type of test framework, please reach out. So now let's get into some of the access control. One of the components, as we mentioned before, is that virtual and physical isolation. And from an isolation perspective, users in this lab are members of an employer. They're either employed by a vendor, they're partners, or they're customers. And so in this case, if you're a vendor that's providing equipment, you can also provide a list of employees that should have access to that equipment. If you have partner companies that you work with for specific integrations or solutions, you can also provide access to those individuals. And if you have customers that are using your equipment, you can do that as well. So credentials are obtained from the UNH IOL. And once you have those credentials, you can then be added to different access lists by the vendor that owns the testbed. So in this case, we have 2 examples. We have testbed from company A on the top, and maybe in that case, they want to grant access to 2 of their own employees and then 1 of their customers' employees to be able to log into the devices to debug the equipment. And then in the bottom, a totally isolated testbed might be a company B providing some equipment and then wanting to enable one of their software development partners to have access to that testbed to debug things that are going wrong. One thing that I'll observe, one thing I'll observe is that at the user level, we maintain these ACLs. For the IPsec tunnels that are established between the clouds and the testbed, we actually have pretty broad access. And the reason why we do that is eventually we want to enable this more dynamic scheduling. And these connections are long-established connections that are approved by the TSC. So we generally give them a more trusted position, while all of the human-based interaction goes through the OpenVPN connection to the lab. All right, so as far as the lab status goes, the good news is this summer the lab was set up and it's ready for new equipment. The vendor switches are starting to get delivered, and we're happy to report that we now have 2 Dell switches that are the first to be deployed in the lab. On the test framework side, we have brought up the IPsec tunnel to Google Cloud, and we're starting to configure our Ondatra tests to be able to run on the UNH lab. We're planning to get the Azure connections for SONiC management set up pretty soon. And then as we mentioned before, we're currently mapping test beds to test frameworks. This is just to help get us off the ground. It's easier to debug, and it's much more predictable if you know the test bed is going to be in the state that you left it. But eventually, we're hoping to switch to test bed scheduling and enable sharing between more than just the 2 frameworks. So next is your job, the call to action. So if you're a vendor and you're interested in providing a hardware test bed to the lab, please reach out to the TSC. We're happy to hear your request and accommodate a new test bed. If you have a new test bed type that you want to propose that isn't a mirror test bed topology, we're also happy to hear that as well. Like, for example, if you want to take a packet generator, a hardware packet generator, and a DUT and put them together, there's definitely space for those types of test beds if you're interested. If you're someone who's part of the broader software development community, please help expand test coverage. Currently, a lot of the SONiC management tests were running just in a vSwitch without a data plane. Fortunately, we'll be able to expand to software data planes through the help of VDP, as well as Alpine, a new software switch that's being contributed. But there's nothing like running on hardware. And so if you want to help us expand the set of tests that are available for hardware, please help us do that. And if you have a new type of test framework that isn't the ones that we've mentioned today, we're also very open to running those types of tests on the lab. Another opportunity is reporting. Guohan mentioned dashboards for results. If you're interested in helping either define what those dashboards looks like, reporting results, or correlating those results to software failures, we're very, very much open to proposals here. So with that, if you're looking to keep up to date, we've got a new mailing list, SONiC Community Lab. And then if you have questions, SONiC Lab reaches out to us. So now's a great time to get involved if you're interested. Thanks.
Sweet. Thank you. Any questions? Yeah, feel free.
I just had a quick question on the software. In terms of, is that again the vendor's choice, or are we trying to run community images? And do we want to run the same across all test beds to get a sense for the dashboard? What's the plan there?
So generally speaking, we're running community SONiC images that are built from the latest mainline. So the purpose of this is primarily to identify the feature compatibility across the releases as we go forward, catch regressions early so that we can start to mitigate those before we get to release crunch time, and then keep the community up to date as to the status of these tests.
And there is a little bit, even for the one test bed, you can do different scheduling. One, for example, one on development branch, and then also allocation on some on the release branch. So in this case, from the end user point of view, they are more care about the release branch quality. And then from the developer point of view, they care about more, the development, the regression, those things. So we can balance that, so that can provide both views to both developer and also the end users.
Makes sense. And so from a vendor responsibility, we don't have to worry about the software image, or would that be the lab's responsibility to kind of make sure that the same build or same thing is running across all test beds?
Go ahead.
Yeah, and so as you can see, when we design those access, we have like 3 layers, right? So there's a lab layer, and there's a vendor, and there's this user. So I think in terms of the testbed maintenance, we also have this new mainly scoop that will have the community member to support in general, right? So those SONiC platform independent features, but there may be some platform specific features, hardware and drivers. I think that is also why we also give the access, special vendors access, so that they can help enjoy and maintain those, not just only hardware issue, but also the software issues to make sure the tests are passing. Yeah.
Makes sense. Thank you.
I can add one more bit to that. So in the most stable configuration, the goal is that there's no human intervention required. We build the images in the cloud, we push them, we install them using the SONiC upgrade process, we reboot and we run the test. So that is the happy path that should be working for most of the time. Now, we know that software doesn't always work. And so if something happens, then the advantage of having the human access is that someone from the vendor or perhaps someone that they've authorized can then log into the box and do some on-the-box debugging, potentially working with partners or customers to figure out what's going on. From that, they might derive a new test case, or they might derive a fix that then can be checked in and applied moving forward. But yeah, the human piece is really just for what happens when something goes wrong. But the primary goal is that we're running 99% of the time just automated regressions that are automatically upgrading SONiC and retesting.
Hi, excellent initiative, first of all. One question to Brian. I saw Ondatra on OpenConfig, and you had a small text there about traffic generators. Have you considered integrating Open Traffic Generator Community Edition into this test framework?
So is a question about Ondatra test framework or a question about the hardware lab?
It's a test framework,
okay,
as well as because in Ondatra OpenConfig there is Open Traffic Generator Community Edition, which is we're pretty active in that community. So have you considered integrating that into this test framework?
It's a good question. I don't have a good answer right now. Okay. I think looking from this in the SONiC lens, our purpose with at least the Ondatra tests for now are primarily testing SONiC configuration paths and SONiC telemetry and state. For data plane tests, we're primarily using pins ThinKit, which is a mechanism by which we can install some forwarding rules and then inject packets and receive packets. But those are typically at very low rate. And so in the context of this effort, we're primarily doing packet testing through ThinKit. That being said, if there's interest in actually building out a DUT to traffic generator topology and getting one deployed, we could certainly explore expanding OpenConfig Ondatra tests to actually do configuration of traffic through a packet generator and validating that using a SONiC switch.
Absolutely, I'll be very interested in talking about it. Just one concluding question is, there are so many competing frameworks in testing in SONiC, in Ondatra, have you thought about standardizing one through this community lab?
Can I just talk a little bit about the traffic generator part? Sure. Right. So actually, I think we are very interested in to test the network device with a high rate of traffic, because the purpose of the network device is to be able to carry the high traffic. Right. So I think through the the test communities, we've been working with different test equipment generator providers to actually leveraging the OTG kind of framework to develop the test on those more hardware capable hardware to do the traffic generator testing. So in this case, I think from the community test perspective, we certainly would welcome those test equipment to be able to, if they are interested in joining and contributing the hardware in terms of those test equipment. I think we definitely welcome that, so we can add more capability in terms of the testing the traffic, and then we have some existing community tests to be able to run on those generators, and then we'll show that okay, hey, because that just gives more confidence to the people that what SONiC is capable of doing that. I think that's a great idea. Yeah.
Thank you. Absolutely. My just concluding question was: are you standardizing the test framework through this community lab? Because there are so many conflicting and competing test frameworks that we have to work with. So I'm just trying to understand which one should be standardized, or do you have a plan to get there?
I don't know that we're ready to standardize yet. I think where the test frameworks that are being driven now largely come from like our internal use cases and our internal ability to have SONiC hardware images that are conformant to what we are expecting. So it's like largely, is a device doing the features that we need, that we need it to be doing, and are there regressions that have happened there? So I think right now it's more about how do we improve the robustness and quality of SONiC images and SONiC releases and keeping mainline stable. That being said, this is a great test bed or testing ground for new types of frameworks, and eventually coming to the frameworks that are solving our problems and getting the coverage that we need. So I would say that it's a little bit early for that, but this is a place where some of that standardization could emerge from down the road.
It's just to add, right? So as you can see, one of the things we're trying to do in this test lab is actually doing the scheduling, right? So because I think what we want to do is that we want to end up with a common, hardware platform that enable all different kinds of test topologies there, right? So therefore, we build the capability to be able to test every port of the switch. Then therefore, we are working on the scheduler where, you don't have to change the hardware, but you can do in the scheduler to test the different, kind of setups, because maybe different users have different use cases, right? So therefore, even within the, let's say, SONiC management test, there's a whole bunch of tests, 3,000 tests, and I don't think maybe user only care about a subset. So, the goal is also try to enable a subset so that, we can actually, test it faster and then be able to get the user what's the results they would like to care about, right? So, yeah.
Thank you so much.
Quick question. So when you said you're trying to get it so the test can be run automated in images, the obvious follow-up request would be, could somebody have a test run automatically on a specific PR before the PR merges? Is this something you're considering, or how you're going to schedule it?
That's a great question. So basically, instead of doing regressions or daily, nightly runs, can we get to a point where we're doing pre-submit? That is, I think, maybe a holy grail that we can get to down the road. But the question that we have now is, when you look at the amount of time it takes to do the build, run the tests, and the sheer number of PRs that are coming into the project, it's probably kind of unfeasible. That being said, I think there's, as Guohan mentioned, like right now we can have the daily or nightly runs for maybe a release branch and the mainline. But if there's a big new feature coming in, we could also potentially schedule some runs on that development branch. Down the road, if we do have an expanded set of test beds and we're having test bed utilization below 100%, based on kind of the demands for mainline and release branches, we could certainly consider or look at using hardware to do pre-submit testing. But I think the more likely outcome is that we rely on software test beds for pre-submit testing. And then after the code is merged in, we'll have n number of commits in that day that'll get rolled up into one nightly hardware test.
Even going not full holy grail, but sake of argument, I'm doing something very specific. Mm-hmm. Let's say some change on an ACL. Mm-hmm. I only really think this will impact switches from vendor A, vendor D, and vendor G. Can I make a request to just do those very specific vendor switches and just a specific ACL test? So not overload the scheduling. Don't run the whole test suite. I'm thinking SONiC management in my head. But just a very specific SONiC test case, and only for this subset of switches.
Yeah, I think this is a very good idea and discussion, right? So where we can improve the flexibility of the scheduler, right? So that allows enable run a subset of the switch and targeted device, right? So and all this and targeted release. I think the way I think there's a lot of enthusiasm on this one. I think that's a very good thing. So I think what we do is that we have set up this working group with this lab and combine with the test subgroup. So together to iterate on this to see what is the best shoot for the community. Right. So I think we'll continue those discussions and in the working group, and then what is the best way to move forward.
Sounds good. Thank you.
Yeah, so join the working group and bring that as a new feature requirement. I mean, I think it's a great idea.
Yeah.
Right. Thank you.
And also call for the contribution of the hardwares.